Well, that over there is an Ethiopian opal. And it is one of my more amazing opals. Prepare yourself to be amazed. Somebody was worried that I didn't know what harlequin meant. And so this little stone has both broad flash and harlequin in it. There it is, there on the side. And you can sort of see it. I've got some crud on there or something now. And there's some broad flash. See what I mean? There's broad flash, and look at the harlequin on the side. It's all perfectly even little squares. And they march up and down this side. Let's see if I can get it. There you go. There it is. So yes, boys and girls, I know exactly what harlequin means. I even know why it happens. About that. So this is a rather bright and beautiful stone. And if anybody tells you that they can dye an opal black and get this kind of color, it's a lie. You can't do that, man. It is physically impossible. And as far as I know, we don't have anything at all that is clear and black that we could add to this stone, or to a stone, to make it do this. That's ridiculous, man. Because, you see, there's nothing red or blue or green in this stone. There is nothing with any of those colors. It is essentially black and clear. The colors come from breaking light, pretty much like a rainbow. They work like rainbows. Rainbows have lots of little spheres of water, and they're way, way, way off in the distance, so that those little spheres of water are exactly half the size of a wavelength of visible light. To you, they of course aren't physical reality in a rainbow, but to you, way far away, those droplets are really small, and that's how small they have to be. So this opal does that, and they're so small. They're half the size of a wavelength of visible light. And as the light passes through this stone, it doesn't give any other information other than the play of color. The blackness is like the blackness of the night sky. It is the light going away from you and not returning any information. It is because the sulfides in iron sulfide precipitate this black opal. And it is made of little spheres of silica. Okay? Silica is pretty much clear. There's some additions with the metals. Okay? So the sulfide causes it to be like maybe more like obsidian type color. And these little spheres absorb light. That's what makes it black. They absorb light. Black is not a color. It is the absence of color.